Alright, so yesterday we did the fundamental counting principle, okay? And we're just going to lead into today's notes. So basically today and yesterday was all about how you count, okay? How you count all the outcomes in a specific event, to now lead into being able to determine the probability of specific outcomes in an event. Today we're just going to be going further into that. Let's practice yesterday's notes with this formula. It says we got a license plate that has 3 letters followed by 4 numbers. Okay? So it says if the same letter or number can be repeated, I say that a lot. Can be or cannot be repeated. There's 2 different ways to handle that. How many can be made? So this is just being able to determine the number of outcomes that you could have. And if that's the case, I always space out and write out all the different options I can have. Like if I'm talking about 3 letters and 4 numbers, that's 1, 2, 3, 4, 5, 6, 7. We got 7 spaces here. Okay? And what the fundamental counting principle says, and I'm just dividing it between letters and numbers here, is to write down all the possible outcomes for each position. Yeah.
26 for the...
Yeah. Exactly. If the first one we're talking about here is the first 3 here, we're talking about letters. Okay? How many letters are in the alphabet? 26, right? And so I have 26 possible outcomes that I could possibly put for that first letter, A through Z. Okay, and it says that it can be repeated. So if I pick like A here, then for the second spot I can also pick A. So 26 again, right? And 26. Those are all the possible like it could be Z Z Z. It could be A all the way to Z Z Z. There's 26 times 26 times 26. Does that make sense? Okay. Now then the numbers here is, I'm talking about 4 numbers here. They can also be repeated. How many numbers or digits, single digit numbers can I pick? 10. Absolutely right. 0 through 9, that's 10 possible numbers. 10 possible outcomes to go here. If they can be repeated, that means I can do the same ones here as well. Does that make sense? Yeah.
175 million.
175 million, is that what you're saying? And then what? I believe that's correct. Yeah, I mean, and like what I could ask is, what's the probability of having a license plate CCK 5040? What's the probability of having that license plate randomly chosen out of all possible license plates? Yeah, 1 out of all that. But we're not there yet. Right now we're just talking about how to find all the possible outcomes. We'll leave that later. Okay? That's kind of what we're building up to. Does that make sense? All right. Yeah. This number right here? Yeah. Multiplying all those together. Was it 7 right here? Sure. You multiply all these. So if you watched the video yesterday, it talks about this is the fundamental counting principle. You list out all your different options, and in each of those spaces, you put the number of outcomes that you could possibly have. Fundamental theorem, fundamental calculus, not calculus. Fundamental counting principle says to multiply all these outcomes. Right. It's based off of that factor tree that we kind of did, Markov chains, and you'll see that in the video yesterday too. Any questions on that? All right, and then another way I can ask it is if it cannot be repeated. You'll see when we start doing card problems, when we're drawing cards and stuff, that'll be a common question. So again, we still have 7 spaces. Okay, 3 of them are letters, the other 4 are numbers. If the letters cannot be repeated, all right, you always work yourself left to right. How many options do I have right here? 26. If it cannot be repeated, so say I pick the letter A here. I cannot pick the letter A here. How many options do I have now? 25. There's 24. Right? And then, letters, it doesn't specify anything about numbers, but it can still be the same. And because I'm a little less here, because I've kind of put some more stipulations on it, it's going to be a little bit less than this number. Probably not that much, but 156 million this time? Yeah, about that much. Or what? Oh, that's it? That right there? All right, that makes sense. Any questions on that? That's how they all are. And like number 2 and 3, those are just like a bunch, like a big chunk of them on your homework. Since you got a, so you got a 5-digit number that can be formed using 0 through 9. We'll say that it'll usually specify. We'll say that they cannot be repeated. I think I just spelled repeated wrong. No, I didn't. Okay, we're good. So we would space it out. 1, 2, 3, 4, 5. We got 5 spaces. How many options do I have on that far left? How many options do I have to choose from? 10. 0 to 9, there's 10 options. I cannot repeat the numbers. So whatever number I pick here cannot be here. So how many options do I have? 9, 8, 7, 6. 30,000. Perfect. What's up? Okay, yeah, now that's a common thing. 10 is not the actual number that I'm using. 10 is the number of possible outcomes that I can put here. So what I'm saying is like I could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 possible numbers. I'm sorry, that's 10 possible numbers. Yeah, 0 counts as a possible number. And then 1 less than that would be 9. Does that make sense? See the difference between? And that was confusing people in homework with the 7-digit thing last night. Number 3 is kind of a typo. It says, how many 5-digit numbers can be formed if each one uses all the digits 0, 1, 2, 3, 4, 5. Let's say 0 through 5. Without repetition. Alright, so again, we have a 5-digit number. 1, 2, 3, 4, 5. How many options do I have for that first space? 6. 0 through 5, that is 6 possible numbers. Can't be repeated. So then 5, 4, 3, and 2. What was it? 7. Cool. And I understand what that number's saying. It's saying there's 720 possible ways to have a 5-digit number using those 6 numbers without repetition. Yes, sir. So that's a different type of stipulation. You still got to figure out how many possible outcomes you can have. We'll do that in 2 seconds, okay? I'll come back up. All right, what about number 4? Very last one. We have 6 bicycles, all right, being parked in a row. Here's my row. They're all parked in a row. You can think of these bicycles right here. Again, start left to right. That's always a safe bet. How many possible bikes do I have to choose from the range right here? 6. Okay, whatever bike I put there, well, how many bikes do I have left to arrange in the second spot? Again, yeah. So anytime that, like, the first choice depends on the second choice, it's going to go down by 1. Okay? So 6 times 5 times 4 times 3 times 2, 1. 720 again? Oh, cool. I mean, oh yeah, that makes sense because this is multiplying by 1. But, yeah. Cool. Any questions on the warm-up? Any issues there? Okay. All right, so yesterday we talked about the fundamental counting principle. Today is pretty much the same exact thing. Okay, same exact thing, but we're just adding to it a little bit and just adding some different notation. We're still trying to figure out the total possible number of outcomes we can have in a situation. We're just using 2 new vocabularies. Okay, permutations and combinations. First one we're going to talk about is permutations. They're very similar to combinations. Those 2 words are very similar to each other. Just one distinct difference. When we group in objects where people are arranged in a certain order. All right, there's your key word there. In an order, a certain order. We're putting them in a specific arrangement. That's usually the key word you'll see in your word problems is arrangement. Then the arrangement is called a permutation. All right, permutation. When we're doing this, we're looking at indistinct objects, okay? And we're arranging R of them at a time. So N is equal to the total number of objects, and R is equivalent to the number we arrange. let me give you an example. I got 10 textbooks, all right, 10 textbooks, and I can only fit 3 of them. I can only fit 3 of them on my bookshelf, and I want to arrange them in a specific order. So how many ways can I take 3 of those 10 books and arrange them on my bookshelf? Does that make sense? Yeah. Now, here's the notation. This describes it. This means taking the permutation of n objects r at a time. This is the formula here. All right, that's what you're doing in the calculator. But dude, I'm not making you memorize that. I'm not making you use that. It's all done with just a button press in the calculator. Okay, so don't worry about that. Well, how we do it in the calculator is NPR. Well, the calculator will do that mess for you. I'll show you how to do that in a second. Hey, that's really easy. Okay. There's only 4 steps. All you have to do is first type whatever your n value is. So in the bookshelf example, I would type 10 for n. Okay. Then you're going to want to get that P right there. So you're going to go, number 2, you're going to go to math, which is like the 3rd button down. And you're going to go over to probability, PRB, which stands for probability, right? So math over to probability, that has all your operations you need in the probability unit, for most of them at least. And I believe it's option number 2, thank you. That's going to have your NPR notation. Okay? And then finally for number 4, you're just going to type whatever your R value is. And it'll compute that formula for you. Okay? So like that example of the bookshelf, how it would be typed in the calculator would be 10. You're going to choose that NPR and then type your 3. Makes sense? Did you get 720? That's correct. Okay. All right, I'll show you how to do that in the calculator in this next example. Those watching the video, just type it like I said. All right, let's do an example. So it says there's 10 finalists. Now, okay, I'm going to go ahead and tell you, doing the math behind this stuff is super easy. Just type in the calculator. The only hard part, the only thing that y'all get wrong on the quiz and test, is trying to decide if it's a permutation or a combination. That's it. Okay? So hopefully I'm going to try to show you keywords that helps you figure that out. But it says you have 10 finalists, okay, in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So here, when I'm taking out my groups of these 10 finalists, does it matter how I arrange them? I mean, think about it. Like, if I'm the first person I'll take out, the first person that comes in would get gold, second person silver, the third person bronze. Yeah, it does matter. It doesn't matter how I arrange them, because the first person would be first place for gold, the second person would be silver. It matters who I put first. Do you see what I mean by that? So anytime, and just a little spoiler here, anytime that I'm talking about any type of thing I'm assigning people, whether it's like medals or like vice president, president, secretary, or first, second, third, anything like that, that's an arrangement. You put it in a specific order. So whenever you do these problems, once I decide that it is a permutation, you got to ask yourself what N and what R are. So what's N? And we got 10 finalists. That's the total number of people. And then R is the amount of people I'm trying to take out to arrange, which is what? 3. Yeah, because you only got 3 places to give away here. Well, crap, we just did this problem, yeah. Yeah, so that would be 10, and then NPR in the calculator, 3, which we just did, and then whatever. 720. Let's see here. What happens when N equals R? That can work. Think about what that means. That if I'm saying like N is my total number of objects, and I let R equal that, what does that mean? How many am I arranging? Yeah. In this case, everybody would be a winner, right? First through 10th place would get an award.
Very close.
We're arranging everything. All right, for this particular example up here, that'd be like taking your 10 finalists and then arranging all 10 of them, giving them gold, silver, bronze, blue. I don't know what colors go after that. Platinum. I probably before gold.
Yeah.
All right, but let's think about what that means. If I do that, first of all, it's a big number. I'm probably not going to write that one down. But I want you to kind of think about, I'm going to go back to this example right here. I want you to think about what we're doing when we're doing NPR. I told you that this is very similar to what we did yesterday. All right? If I had given you this problem yesterday, you could have solved it as well. All right? Yeah, hopefully. What I'm saying is if I have 3 places, gold, silver, and bronze, how many options do I have to give somebody gold? 10. There's 10 possible people that could come down the finish line first. Then the second person to come down, how many options do I have for silver? How many options do I have for 8? All right, 720. So what NPR does is it's telling you where to start. This second number 3 here tells you how many times to go down through. So like 10 and then down 3. It's the same thing we did yesterday. Okay, it's just for the examples where there's no like when you can't repeat something or when you're just going down by 1 each time. So if that's the case, in this case N or 10P10, that's the same thing as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because that's what I'm saying, like do it down by 1 10 times. What's that the same thing as? 10 exclamation point or 10 factorial. So really if the n value is equal to the r value, it's just the same thing as n factorial. Okay? Same thing. So here's a good example. I mean, if we have all the letters in the word Tuesday, Tuesday, how many ways can you arrange all those letters in the word Tuesday? Well, first ask yourself, first of all, what is n in this case? Yeah, there's 7 letters in Tuesday, and I want to arrange all of them, so that means my r value is also 7. So in the calculator, what you could do is 7p7. Take all 7 of them and arrange all 7 of them. But it's also equal to 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't even know what that is. Anybody get it? 50, 40? That's all that. What that means is there's 5,040 possible ways to arrange all those letters in Tuesday. No. Nothing. So I could ask, what's the probability of it being Tuesday-yad? What's the probability of having the word Tuesday-yad? 1 out of 50, 40, I don't know. Tuesday-yad. Day twos. Tuesday is day 2 of the work week. That's pretty clever. Wednesday.
Shut.
Okay.
Yeah, let's
We're shut.
Monday is the first day of the week, and Wednesday is the
Alright, that's pretty clever. Let's keep that going. We got 2 for 2. What about wed? Like wedding is the middle of your life.
And you have to have 3 people there to actually get married.
2 people and a witness. Wait, 4 people then.
What?
No, you gotta have a witness.
Yeah, the person who marries. The person who marries.
I don't know, we're getting off on a tangent here.
That's 3, so that's third week of Wednesday. Thursday.
I think I should pause the video real fast.
Third.
In case you're wondering how to do factorial, it's the same menu as NPR, it's just number 4.
So NPR is the same thing as factorial.
NPR is the same thing as factorial, but it cuts it off at a certain point. Here, if I do NP3, 10P3, it means it cuts it off at that third one.
Okay.
So it's the same thing. Same exact thing. Okay. All right, let's go on. Ooh, here's a good example. This is something I want you to, in our probability unit, this is really the only formula you have to memorize. Okay? It says, what if the letters repeat? So, like, look at this example here. Like, Mississippi, Mississippi. What if I'm talking about all the ways that you can arrange the letters in Mississippi? Well, here's one arrangement. Me switching these two S's. That's one arrangement. Is that any different? Nah, just changing the same letter back and forth. That's not any different. So if the letters repeat, doing n factorial is not good enough. Okay? So that's the first step, though. You want to do n factorial, but you want to then divide out the repeating letters. Okay? So here, first of all, how many letters are there? 1, 2, 3, 4. 13. I think there's 11. Good guess there. So this will be 11 factorial. But if I do 11 factorial, yeah, it'll tell me all the arrangements, but it'll tell me all the ones that are repeating too, and I got to divide those out. All right, so what the formula says to do is to do your n factorial, and if y'all think of a better way to write this, please let me know. You divide by the number of times each letter repeats. Factorial. I know that sounds weird, but let me talk about what I mean. You start with each individual letter. So, like, let's start with the first letter that repeats, I. How many times does I repeat? 4. So if I did 4 factorial to represent all the times that I repeats itself, that's the number of ways that all the different arrangements of just the I's. So basically I'm dividing out all those repetitions, all those repeating arrangements of just I. Okay? And then you also have to do S as well, so there's 4 S's, so 4 factorial for your S's. And then 2 factorial for your P's. I think that's it. So like I said, I mean, what we're doing there is we're just dividing out all those repeating arrangements that are the same. So again, I mean, that's done, right? So do that in a calculator, type it in exactly as you see it with all the factorials. 11 factorial divided by... Huh? No, these are all multiplying. If you want to put multiplying, you can, but just if you type it just like this, it'll work out.
7.
Oh, God. 7, 9, 8, 3, 3, 6. Yeah, I think Kevin's right, if I remember right. What'd you say?
3, 4, 6.
That?
No 8.
No, it.
No 8, and then you're
3, 4, 6, 5, 0.
Yeah, literally no 8.
Maybe somebody just said like grade or something. I was like, cool.
That's the problem.
Yikes, that's a long time. Alright, so this next one goes by a lot quicker because now we know what a permutation is. Combination is the same thing, just a little bit different. You do the same exact steps, same exact process. You just have to identify the difference between the two. That's it. Okay? So now we're talking about an arrangement or selection of objects which order is not important. Order is not important. We're just taking out groups. Okay, we're taking out distinct groups. That's called a combination. So like an example, let me give you an example. I got, okay, sure. I go to an ice cream store. They got 15 flavors of ice cream. And I want to know all the possible ways I could take out 3 different groups of flavors. Doesn't matter how I arrange them. What matters is that I'm getting those 3 flavors. Just groups of different distinct flavors. Okay? Keywords here would be like groups. If you ever see the word choose, that's another keyword. Okay? We'll see as we go through these problems. But again, n is still your total. And your r is the number of groups. So like the number of groups I'm trying to take out. Okay? Here's the formula for this. Again, you don't need to know it, you don't need to memorize it. You can if you want to, it's a nice formula. But we do it in the calculator. Alright, the calculator, it's in CR. This is in the same menu as the last one, but there's a little bit different notation that people use with combinations. Okay, I use it all the time in probability. Any higher level math will use the same notation, and it's just the way you're supposed to write it. It looks like this. That's how I'm going to write it from here on out. That's only with combinations. Okay? This is not n divided by r. Don't put the little division symbol. We're not dividing each other. This notation is saying, literally how you read it is n choose r. What that means is that of your n total number of objects, I'm choosing r of them. It's cool if you actually go to Wikipedia and you like Google and Google search like the probabilities of getting different hands in poker. It shows you the math behind it, and it uses this notation because all it is combinations. It's pretty cool. I was interested in that at one point in my life. Didn't work out for me. So, anyway. All right, calculator step, still the same. You still want to type in. All right, number 2, you still want to go to your math and over to PRB. Okay. Number 3, you want to choose not number 2 now, you want to choose number 3. That one says NCR. And then lastly, just type whatever R is. Okay. Same exact steps. Just number 3 is a little different. Let's look at an example. I got a couple more. It says a group of 7 students working on a project. We got 7 total people here working on a project. Needs to choose 2 of them to represent and present their reports to the class. How many ways can they choose 2 students? All right, look. Keyword here is choose. That's usually an indication. But also, if you're ever trying to decide between the 2, you just got to think about it logically. Ask yourself, does it matter what order those 2 come out in? Am I assigning first and second place? Am I giving them roles of speaker and slide changer person? Like, am I doing any of that stuff? No, I don't care about any arrangement. I just care about distinct groups of 2. Like, I don't care if I take like Bob out before Sally or Sally out before Bob. I just want to know the different groups I can take out. Permutation would say Sally then Bob is different than Bob and Sally. The combination says, who cares? I just want those 2 groups. So your answer will be a lot less than the permutation. Anyway, what's n equal? What's r equal? Okay. So it would be 7 choose 2, and again, how I write it is 7 choose 2. Okay. So go to the calculator, do it exactly like I wrote it, 7 in your C, then 2. That number should be a lot smaller than, say, 7p2, because the order doesn't matter. Those aren't distinct. There's like 20 something. 21? Cool. And this is not like what we did yesterday, so you can't just like multiply them across. There's no way to do that. This is a little bit different. Okay. 21 possible ways I can do that. Oh crap, I used the example from here. How many different ways can you choose 3 of 15 flavors of ice cream in a grocery store? Again, it doesn't matter. It doesn't matter to me taking those 3 flavors in any specific order. I just want like strawberry and chocolate and vanilla. I don't care which one comes first. I just want to take out those groups. So n is 15. R is 3. So you want to do 15, choose 3. 455? Yep. Now, if you were to do 15p3, that would arrange those flavors. It's almost adding a bunch extra. That would be a lot bigger number. That would be 15 times 14 times 13, which is a lot. All right. Dude, I'm thinking about ice cream all day. Questions on that? All right. I got one more example, and if you don't get this example today, totally no big deal. It's the other ones I'm more concerned about. This one's going to become a lot more handy when we get to our probability portion. But what if you have multiple events? Okay, if you have multiple events, it's all about multiplying. Okay? That's what you do. In this case, we do have multiple events. We're talking about a lot. Since we got 5 cards. Yeah, we got 5 cards total, taken from a standard deck of cards. I use deck of cards a lot, Okay, so if you don't know a deck of cards, we're gonna talk about it. We'll figure it out together. No big deal. It says how many hands consist of 3 clubs and so we got 2 separate things here, 2 diamonds. Okay, I got 2 different categories here that are independent of each other. And I know that I'm not choosing these myself, but when I say choose, I mean like cards that are chosen for me. Okay. So I got one that I'm gonna have to do for clubs, and one that I'm gonna have to do for diamonds. So just think about clubs specifically. We'll do more practice this later, but how many clubs are there in a deck of cards? 13. Yeah. Yeah, so there's 4 suits in a deck of cards. There's clubs, spades, diamonds, and hearts. 13 of each. So there's 13 clubs. How many am I choosing? 3. So you take the total of the category, choose how much you need, and then how many diamonds are there? And we're choosing 2 of the 13 again. When we get to probability, we'll see, kind of why this works, how we divide this up. It'll always be the total on top, and on the bottom, just how we split it up. What was that equal? Okay. So that's all possible ways that you can have that type of situation. On your homework, there's one problem like this, and I believe it is a permutation. All right, well, hope you enjoyed the lesson. Good luck on your homework. It's the backside of yesterday, blah, blah, blah. Okay, bye.